Think building your own guitar effects pedals too hard? Well, watch this, and I'll show you how easy and fun it can be to start building guitar effects pedals in 2025. With any guitar effects pedal, the first thing you need to do is plan the layout of your enclosure. We need to know whether all of our jacks, pots, and our 3-pole double throw switch is going to fit inside the enclosure. Then after that, we need to drill the enclosure to the right size to make sure it fits all of the parts. When it comes to enclosures, no two are created equal. As you've no doubt seen in the past, I like to use these standard style enclosures and spray them in nitrocellulose lacquer. For a beginner, this would make the most sense, and that's why we're going to be using this enclosure today. However, while we're drilling our enclosure, we're going to be using this enclosure. This is one of the new style sloped enclosures that I've started using. I usually cover these in Tolex. If you're interested in a video about finishing pedals either with nitrocellulose or with Tolex, let me know and I'll film that soon. If you're interested in getting one of these enclosures yourself, get in touch and I'll let you know where you can find them. To mark out this enclosure, we're going to need a few things. First of all, I usually use a set square to make sure that my lines are straight. However, as you can see, the sides on this pedal are angled, so that makes that absolutely pointless. We'll put that to one side. If you're using the square style enclosure, I highly advise you get yourself a set square. The next important thing is an engineer's rule. Now, I definitely didn't steal this off a warship. I stole it off a warship. Yeah, I definitely didn't steal this off a warship. Apologies to anyone in the Navy who's watching now. I find that the metal steel rules are much better. Because I'm English, I'm going to go with millimeters because that's a proper measuring tool, not this fake measuring stuff on the back. I'm sure my friends over the pond will appreciate that being there, but for me, it's just decorative. So, you need this. And then I also highly advise that you get one of these. It's an auto punch. So instead of marking out your pedals and a drill bit slipping everywhere, we give it a punch with this, and it gives the drill bit something to center on. Now, you can buy a cheaper metal punch where you have the hammer. For me, that's just too much faffing about. This is what you want. Another thing you're going to need is, of course, all of the components. I like to start off by putting in the 3-pole double throw switch. So to mark that off, I usually go 20mm. Apologies for my American friends. I'm going to be using millimeters. 20mm from the bottom and then roughly again from the side. With this, because it's not lining up to anything, it doesn't really matter exactly where you put it, as long as it fits inside the enclosure. Now, I know before Craze Fandango comments on this video about the off-center switch, he likes them in the middle. I get it, some people like that. But I like having the extra real estate to fit big components into my pedal. This one's actually going to be a Stevie Ray Vaughan tube screamer on tagboard, so that's interesting. So we're going to go about here. Now, I do advise that you measure the 20mm up and 20mm across if you're in a more restricted enclosure, but I've got plenty of space here, so I'm just going to bang a mark in there. Now, hopefully you can see it's put a little indent into the enclosure, which I'm going to use as a drill guide. There's nothing worse than a pot's looking off center. It just makes everything look a bit wrong. Now, when you're building with one of these, if you want, you could purchase something like this. This is a drill template from my buddy over at 5 Cats Pedals. It's fantastic. And I like to take this template, put a bit of tape over the top, as you see. I use painter's tape. Measure it all up so then it's even round the edges. Put the tape down. And now you've got a nice handy guide, as you can see. I've clearly been following it on this one, that you can just punch holes and check that your components fit in the right spaces. It's great. However, if you're only building one pedal, it seems a bit silly to pay out for a drill guide when, you know, you could just measure it out yourself. So we'll go through the measuring process just in case. As far as the pots go, I like to make sure that they're 15mm away from the edge as a bare minimum. This allows you to use any sort of knob that you want. I used to, when I first started building, try and squeeze them right against the end of the enclosure so then I had more space inside. However, that meant that when I was using larger knobs, the knobs would overhang the enclosure. It just doesn't look right. So minimum of 15mm. As you can see, This pedal is absolutely massive. So I've got plenty of space, and I'm going to use large, very large knobs. So I might as well go about 20 mm. What I am going to do is lay my rule up against the back edge of the enclosure. Now, if you're painting your enclosure, I don't advise doing this. You may want to get yourself a pencil and scribe a line across with a pencil. But because I'm not painting this enclosure and it's going to be fabric covered, I'm just going to scribe a line across it using this. Now, I don't know if you can see that. That will be visible through the paint. So you don't want to be doing that if you're going to be painting your pedal. Now, I can just lay my ruler across this line and measure out 20 mm from each end. Now that we have our holes marked out, it's time for the final test just to make sure that the pots are going to fit without any issues. So I just like to line them up like this, sort of behind the dots that they're going to be in, and I can see that there's a nice spread between them and they're not overhanging the enclosure. I'll be able to add my jacks in between them. It's all looking good. Now the question is, where do you put your LED? Now for me there's three options. One, you can put it up here between the pots. Because I'm building an overdrive, this is going to be a tube screamer. It's an overdrive with 3 controls. There's space in between the pots with no switches, so I could put the LED up here, but it kind of complicates things when you're wiring stuff up. I could put it over here, which keeps it out the way and leaves this space free for the circuit. Or I could put it down here, which makes it more symmetrical because we've got the 3-pole double throw over here. And I know Craze Fandango hates the symmetry being off, so we could put it there. But then it takes up some space that I could be filling it with vintage components. I'm going to go ahead and put mine over here. And that's because that's where I normally put them. I don't normally measure out the LED because I've put that many in that I kind of know where I like it. And I'm going to go there. And there we have the top of our enclosure marked out. Now onto the rear of the enclosure. This is where it starts getting interesting. There's 2 options as far as I can see. The first option is to have your 2 jacks spread out evenly, like so, and then your power jack in the centre, bang in the centre. Now, this looks good. However, in my mind, Bill Finnegan got it right with the Clon, where he offset the input and output and put the power jack over here. I just think that looks so much better. And when you're wiring it up on your pedal board, it just makes it so much easier to have the power out of the way of the input and output. Let me know what you think. I'd love to know whether you prefer the input and output to one side or the 9-volt jack in the middle. Now, before you say a Craze Fandango, I'm talking to you, mate. I know you're going to prefer the symmetry of having it like that. But for me, I like to be a bit different. As we can see, our enclosure is about, there's a bit of parallax error going on here, but I'd say it's a little over 35 mil. Now, usually 15 mil up from the bottom is where we want to put our jacks and our DC connection. I'm going to go a little bit higher than that because this enclosure is quite big. I'm going to go 20 mil from the top. So roughly there. Now, this is where the set square comes into play. We can mark that out with our set square. Again, I advise that you do that with a pencil if you're planning on painting this enclosure. Right, and as you can see, I've only marked the left hand side, and that's because my set square is tiny and insufficient. However, that's where my 2 jacks are going to go. If I turn this over and have a little look, what I don't really want to do is position a jack smack bang on top of the pot. It doesn't matter because this enclosure is really deep, so it won't foul the top of the pot. However, if you're building with large vintage pots that are bigger than these ones and you're putting it in a smaller enclosure, that's something you may want to consider. For me, I'm going to try and aim for just past this pot here. So to me, about there. And if we line up on our line, there we go. That's going to be our input. And now our output, I kind of want to get that just past this pot as well. So it's not on top of this pot, but it's to the side of it. And I'm going to go about here. Luckily enough, our line did stretch that far. And there's our input and output jacks. Now, Mr. Finnegan didn't just put the 9 volt at the same level. He went a bit lower down. And I'm going to do the same because, well, if you sell as many pedals as that man, you can't be wrong, can you? Let's face it. And I'm going to go there. So we've got our input, output, and our 9 volt power supply. When it comes to drilling your enclosure, not all drill bits are created equal. Now, I've been through hundreds of drill bits trying to figure out what's the best way to open up them holes so then they can accept components. I've started off with single drill bits and building up to the right size like you're supposed to, and how the Navy teaches me to do it. However, that's not very efficient, and it's also a pain in the... For me, I like to use a stepper bit, just like this. All stepper bits are not created equal. The gold ones that you get in a little black pack with 3 of them in there that look amazing and look great value, they're not. In fact, you'll probably get 1 or 2 pedals out of them. So if you're planning to build more than 1 pedal in 2025, I suggest that you don't buy them ones. Instead, I would go for this. Now, it's not cheap. This is about £30 here in the UK, but it's lasted me at least 12 months and I build a lot of pedals. I'll put an Amazon affiliates link below in the description. I really do appreciate your support using the Amazon affiliates link and helping me purchase more kits. If you're not planning to build more than 1 pedal in 2025, I'll also put a link for the 3 gold stepper bits in the description below. As far as drills go, I'm assuming that everyone has access to a drill. I mean, come on, who doesn't like drilling stuff? If you don't have access to a drill, then buying the cheapest one may be the best option if you're just planning to build 1 pedal. However, if you're building lots of pedals, then I really had good luck with this Milwaukee drill. My father-in-law, Glyn, bought me this for Christmas maybe last year, believe it or not, and it hasn't missed a beat. I use it almost every day. In fact, most of the time, I don't bother using my pillar drill because it's just so convenient and easy to get this thing out. As far as drilling the enclosure goes, you could hold the enclosure, take your drill, and this is how I did it for years, and then just drill away. I don't advise doing that because the enclosure can slip around and spin and you can cause yourself some real damage. So if it was me and I drill a lot of these enclosures, I would get something like this. It's a drill clamp. Now, it's probably not necessary for anyone who's not doing hundreds and hundreds of enclosures. It's pointless buying one of these just to build 1 pedal, but it's so heavy and there's no chance of this pedal spinning off and hitting anything. Now, for most pots, definitely the pots I'm using and the 16mm pots, 3 steps on my stepper bit is going to take us down to the right width or diameter, sorry, for the pot. So for our pots, I'm going to go down 3 steps. And as you see, that was 3 drops. I'm going to do the same for the other pots. For the way that I do the LED, I go down 1 step. But if you're fitting an LED bezel, it's probably best to measure and see how many steps you need to take. But for me, it's just going to be 1. And lastly, our last hole on the top is our 3-pole double throw switch. Now these usually take 5 steps. 1, 2, 3, 4, 5 on the drill bit. Most of the ones that I've used take that. There are 1 or 2 that are a little bit larger, but I advise to drill for 5 and then test and see where you are. So I'm going to drill that in now. It's so weird drilling to try and stay out the way of the camera. I'm like at a real funny angle here. Anyway, I'm sure the internet will tell me off for drilling them wrong, but that's what I would do. Now, of course, I need to get to the back here. I mean, that's looking pretty good, but I need to get to the back here. Now, usually you could hold it and drill. It's a little bit dangerous. Your hand's going to be in the way, or you could hold it here and drill here, whatever. I'm going to attempt to hold it like that in the vise. Another good way would be to lie it on a flat surface, hold the drill bit side on and go this way. So clamp it down with your hand and go this way. And actually, thinking about it, that's exactly what I'm going to do now. I'll clamp it down with my hand, so then it's tight up against there, and then I'll just drill through the back. Our 9-volt jack is 5 steps on the drill bit. So if I line that up there, 5 steps. Five steps. I tell you what, I'm not looking forward to cleaning up this mess on my desk. I don't normally drill here, but I wanted to film it. And then our input and output jacks, the ones that I use, these type of skeleton ones, they're 4 steps on the drill bit. 1, 2, 3, 4, yeah? However, if you use the older cliff style jacks, the black ones, the big barrel ones that you find in something like a fuzz face, they're 5-stepper bits. So it all depends on what jacks you have for your kit. But for me, it's going to be 4. There. Now we have our top of our enclosure drilled out for our pots, LED, 3-pole double throw switch. I'll be able to put some nice artwork, probably a badge or something there once I've wrapped this pedal. And then also we have our input and output jacks and our 9-volt power supply. While we're here, a quick disclaimer. The drilling is probably the most dangerous part of this. There's been many a time when I've pushed too hard with the drill and it's caught, especially if you're using a cheaper or blunt drill bit, it's caught the enclosure and took it with it. Which is why if you're building many of them, I'd say get one of these clamps, or make sure that you get a good drill bit, because if you get one of the shall we say less quality versions, after a couple of pedals it'll dig in and it'll take the work with it. So do be careful. Now that we have our freshly drilled enclosure, it's time to start adding in all of our switches, jacks and pots. When it comes to populating our enclosure with all of our switches and jacks, I like to use these rocket sockets. They're fantastic. I'll put a link in the description below so you can get a set yourself, but it's not an affiliates link. I get absolutely nothing from it. I just think these are great. First up is our 3-pole double throw switch. There's a few things to note here. Anyone who's watched my videos or seen my pedals will know that I'm not a fan of these PTFE washers, so I'm not going to use that. On this pedal, normally I would use silver, but on this pedal, because the yellow, I'm going to use this fibre washer. I think it looks nice and it'll match the knobs that I'm going to put on there. What I like to do also is to wind out the second nut on our 3-pole double throw switch just a little bit, and that means you don't have a large amount of switch sticking out the top of your enclosure. Depending how thick a washer you use, depends on how much winding you can get away with. But I like to leave the bare minimum sticking out the top. Then we place this lock washer on. I see a lot of people putting a lock washer on the outside, and I've even done it myself at times, but that's wrong. The idea is that sits underneath and grips the enclosure to stop this from moving or unscrewing. Another thing to note is on most of the 3-pole double throw switches, you'll see a line going down it. For some reason, that line, I always have to have it facing the top of the pedal. There's something in me that means that has to go that way around. I don't know what it is. It bugs me out when I have to. Sometimes if I've drilled too close to the edge here and it won't fit in straight, I have to angle it, and it just really bugs me. That's when I haven't measured out the 20mm either way for this switch to go in. You can tell which pedals I've done that with. Then we've got our fibre washer, and of course you could use the white PTFE washer that comes with them, or you could use something else. But for me, in this particular pedal, it's going to be a cut-off drive, this one. So in this particular pedal, I'm going to go with that. And as you can see, there's very little thread sticking out the top there. And I just think it looks better. And then I take my 14mm, get on, for you American guys. Not inches, not anything, millimeter. I take my 14mm rocket socket, just give that a tighten, make sure it's straight, and then give it a final tighten. Next, or usually first, I like to fit the DC socket. Reason being is, if you put your pots in first, it's really hard to get in to tighten up the DC socket. And I can see already that I've put this really close to the edge here, and it's going to be a nightmare to tighten anyway. As far as the DC socket goes, I also like to put it in so that then the socket part of it is at the bottom. I don't know why. I'm not sure if that's a standard thing or what, but I just like it that way round. Then place the nut on. You can of course put a washer on this. I know JHS uses an extra PTFE washer in this position, which is great. However, I haven't left much room between that and my jack. And as you can see, I can barely get the rocket socket in there to tighten it up. Which is why, if there was a pot in the way, I definitely wouldn't be able to get it in there. And I'd have to use some sort of spanner, which, you know, I do from time to time, but I prefer not to. Right, okay. So there we have it. Our 9-volt jack is in. Next is going to be the pots. The reason being is, once the pots are in, I can then put the jacks over the top. However, if I put the jacks in first, I've got to squeeze past them to get to the pots. I've made these mistakes so many times that I can't even count, which is why I know that you're going to appreciate not making the same mistakes as me. So when it comes to the pots, this particular pedal has a 100k, a 500k and a 50k. It doesn't matter what configuration you have. You may have five different pots or 5 different control switches or whatever. It really doesn't matter. But as this is a cutoff drive, there's going to be 3 of them. Some of the pots have this little annoying lug just here. If you can see that right there. Now what that's for is some of the old enclosures had a small hole drilled in that this would slot into and lock the pot into place. It's a great idea, but I don't drill that extra hole, and I don't think you should either. What I think you should do is take your amazing Nipex snips that you've definitely bought by now. Take your amazing Nipex snips and just snap that bit off, and then that way the pot will sit flush up against the enclosure and you won't have any issues. Things like these, I thought this was an alpha pot, but it doesn't say alpha on it. Anyway, things like these pots don't have them on. And again, this pot does not have them on. Also, when you're buying your potentiometers, there's something to think about. These loops or lugs are much easier to use for the first pedal build than something like this. This is meant to go into a PCB where all of these lugs would just slot into the board and then you'd solder them in. But I buy them just because sometimes you can find the right values in these type of pots as opposed to the lug type. This particular pot come from my buddies over at Pedal Pawn. They sold off a load of their old stuff that they weren't using. So thank you very much, guys. I really appreciate it. Aren't they doing fantastic? They've just got their new space sorted and it just seems like they're everywhere at the minute. Anyway, I like to bend these pins over and it creates almost like a hook that I can hook wires round in the future. So as far as the cutoff drive goes, our volume pot goes on the left here, and once it's through the enclosure, it's just one washer on, and then the nut. One thing I will say at this point is, don't tighten these up too much. All that happens is it doesn't get any tighter, but the inside here is a shaft that goes down into the pot, and all you will do is end up pulling the shaft through the top of the pedal. It just breaks the pot. There's no point. I would make sure it's straight and then give it one little tighten with the Peppers pots. If you're using an adjustable spanner, remember that the adjustable spanner is metal and it's going to have a lot more force behind it than something like this. It's longer, so you get the torque, all of that jazz, and you don't want to damage these pots. Now that our pots are in place, it's onto the jacks. I like to use these jacks. They're kind of like the Switchcraft style of jacks. I really like them. It's a bonus to me that they come on old Fender amps. These are like a modern recreation, but yeah, these are my preference. So I like to take off the nut and then orientate the jack so that then the earth is pointing upwards. Now you can tell the earth because it's the lug that's attached to the center hole of the pot. The other lug, the larger one, is attached to this here, which carries our live signal. So if I orientate this lug at the top, it means that I can put an earth sort of buzz bar across to the other jack, makes them both stable, keeps them both together, and it means I can run earth wires to it as needed. So how does that look in the enclosure? Well, we just take our earth at the top, put it into the enclosure, and then place back on our washer and our nut. And then we take our 12mm, well for my jacks it's 12mm rocket socket, and give that a tighten up. Again, you don't have to use rocket sockets or any of this fancy stuff. You could just use an adjustable spanner. It'll do the job just as well. But if you're building a lot of effects pedals, it kind of gets tedious messing about with spanners when you could just easily socket it up. And it has the added bonus that this plastic isn't going to mark your enclosure. And before you say it, I know it's a relic, so it doesn't matter. But I don't like the idea of putting marks into the enclosure that I didn't decide are going to go there. As you can probably hear outside, it's blowing an absolute gale. It's New Year's Day here in the UK. Thought this was an appropriate video to be filming, you know, the first pedal builder 2025, and get it filmed on New Year's Day. I'm hoping to get it out tonight actually, but we shall see. The jury's out on that one. Now there we have everything populated inside our enclosure. Now it's on to the most confusing bit and potentially the most rewarding bit, wiring up the pedal. We're going to look at how you wire up the input and output jacks, the 3-pole double throw switch, and also the 9-volt power supply and the LED. As a next step, I advise after this video to go and look at one of my other videos that show you how to build the actual circuit for this pedal. This part of the video can be applied to all of the effects pedals that you build from now until forever. When wiring up your enclosures, I find it easier to follow the signal path first. So for me, I'm going to take my silicone wire. When it comes to wire, I highly advise that you look at a silicone wire. The reason being is you can put as much heat into that wire as you want within reason, and the wire will not melt. What I see a lot in beginner builds is someone putting too much heat into a wire, which happens when you're just starting out, and it melts the insulation. It just looks sloppy, or sometimes it can short out on other things, maybe the enclosure. I advise getting a silicone wire, and of course, I'll have an Amazon affiliates link in the description showing you what wire I still like to use to this day. If you want to spend a bit more money, then there's always the option to go vintage and buy some cloth covered wire. Now this is really expensive and a little bit difficult to use, especially for the beginner. So I advise doing your first build with silicone wire and then moving over to the cloth. So I'm going to take that wire, strip the end, and that's another benefit actually. If you've got the Nipex snips, you can just grab and strip this wire and it strips beautifully without any messing about. And then we'll wet the tip. Hey, I'm never going to get tired of saying that. Tin the end of our wire because I'm using multi-strand wire, which means that there's lots of little wires inside twisted together. And if I tin it, it becomes one solid wire, which makes it easier to work with when I'm putting it through our lugs. So first of all, I'm going to go through the live lug on the left-hand side. Now, why the left-hand side? This is going to be our input. The amount of times that I've wired up pedals and they haven't worked because I thought input to the pedal, right-hand side, and you wire this up as the input. But when you turn the pedal over, we can see that that is actually the output. So what you've got to remember is input is on the left, output is on the right when the pedal's upside down. Yeah, I've literally not ruined, but ruined pedals or ruined my time, or like fault finding, figuring out why it works in bypass, but it doesn't work when the circuit's engaged. And it's always because I've wired that up as the input. So we're going to wire up we're going to solder in our input wire. Like so. Just take off the excess there. And then I like to tuck the wire right the way around the back of the enclosure just to keep it out the way. I mean, you could run it straight down the middle if you want. It all depends on how you want the inside of your pedal to look. I say this all the time, is that when you look inside of a pedal builder's pedal, you can kind of see their signature. Like if I was to take the back off a Marcus Reeves pedal from Reeves Electro, you would see it pretty much straight away. You'd know exactly who built it. And the same goes for someone like Stu from Tate Effects. His wiring is like absolutely immaculate. I've seen him sell pedals for cheap just because he didn't like the wiring. Nothing wrong with it whatsoever, just he didn't like the wiring, which is insane to me. Anyway, so this input is going to go to the center lug on the left hand side of our 3-pole double throw switch. That is the input. When we switch this switch, the lug either connects to this front lug here, which is going to go to our circuit input, or when the pedal is off, it connects to this lug here, which we're going to put a small little link wire in. The link wire will go round to here, and you guessed it, this lug here is our output. And so this output will go round and go to the output jack. So when the pedal's not engaged, the signal comes in here, round this wire and into the center lug. Goes from the center lug, it's connected this way, goes round to that, which is also connected this way, to this lug here, and then to our output. When the circuit's engaged, these three lugs here in the center connect to the forward lugs. And so the input comes in, it'll go to the center lug, then it connects to this one. This then goes out to our circuit, goes through the circuit, gets all the boosting and lovely tone shaping, and then it comes back to this lug here. And of course, because these lugs are connected together, it means that this lug here is connected here, sends our now boosted or overdriven circuit round and out through the output. I hope all of that made sense. If it doesn't, please let me know in the comments and I'll try and elaborate and enlighten you on exactly how this switch works. There is, of course, another element to it. The center row, so this is like a separate switch. If you like, what you want to think about it is 3 separate switches. You've got the center position of the switch, and it either connects this way or this way. But this center row here, that is what we're going to use to switch on our LED. And that's why we don't use double pole, like with 2 rows, as opposed to 3-pole. We use 3-pole because we want to switch our LED while it's true bypass. Now, as I said in numerous other videos, I like these 3-pole double throw switches that have gold pins. I think they solder just a little bit easier, which means that you can get the heat on it for less time, which then means that there's less chance of damaging the switch. Because these are one of the things that can be damaged by heat. I'm not saying stress and go fast on anything. You want to be able to solder it properly. But just be wary you're not holding your soldering iron on there and unsoldering it, soldering again for hours on end. It'll clearly break the switch eventually. If you've been watching this channel for any length of time, I'll be willing to bet that you've seen me talk about this. My Hakko Soldering Iron. I absolutely love this soldering iron. It's done me so well. It's travelled the world with me, and I know I say this all the time, but it really has held up well. I'd advise spending that little bit more money on a soldering iron, and then that way you know it's A, going to be future-proof, so when your builds improve, your soldering iron will be able to keep pace, and B, you're less likely to get them dry solder joints that thwarted many of my early pedals. I must have built like, I don't know, 20 circuits before I got one to work. If you don't want to build more than one effects pedal, then I suggest that you buy the Draper soldering iron that I have linked in my affiliates link in the description of this video. This is an Amazon affiliates link, and as such, I get some money from your purchase, but there's no extra cost to yourself. Following on from our input wire, I'm then going to put on our bypass wire. So for this, I take a small length of wire, strip both ends, like so. Give them a twist so then all of the little wire strands are kind of together. And then I like to run out my solder. It's much easier to do with this Hakko solder dispenser. They're fantastic, and if you're going to build many pedals, I do advise that you get one. So then I wet the tip. All I'm doing is running some solder onto the exposed metal ends there, like so. And that gives me the solid core at both ends. Now, I've obviously stripped that back way too much. So there's going to be loads of overhang, which is fine because I can snip it off afterwards. But I like to just clip them short while I've got it in my hand. That's a preference thing. It doesn't really matter which way you do that. And then I use my snips, and this is the bit where I squeeze too hard and snip it in half and have to start again. And just position the 2 metal bare ends through the lugs at the back there. That's going to be our bypass signal. Then I'm just going to solder that in. Like so. I do like to just, once it's soldered in, I like to just snip off the excess that's poking through. It's probably not going to foul anything, it's not going to touch anything, but just out of, well, habit, I suppose, it just stops it snagging on anything. Not that it's going to. Next, we're going to run our output lug round to our output jack. Now, you can go round this way, which is nice and easy to see. I like to go round this way, so then there's only one wire trace going around the board. It doesn't really make a difference, but it makes it look a bit neater in my mind, or my opinion. So I'm going to run it that way, but it's up to you which way you run it. As I say, you could run your wires straight down the centre of the enclosure, which is absolutely fine too. Actually, while we're talking about it, this little link at the bottom here, I probably wire that in as the last thing I do in the pedal, just so then I've got access to the switch. But to make it more logical when we're talking about it, I thought maybe we should wire it up now, you know. Now my output lug is really close to that 9-volt jack, because I'm terrible at measuring out and drilling. So don't really want to hang about too long on the heat there, just in case I damage that in some way. There we are. And now I'm just going to run this wire in the same fashion right the way around the outside of the enclosure, round the back, and then to our switch. It's just going to come round and go to this pin here, take a measurement, give it a snip, and then I can just strip the end with my snips, give it a tin, and we should be good to go. I don't advise using your snips to hold these wires and put them into place. There is flat nose pliers, I haven't got them on the desk in front of me, that you can use. There'll be an affiliates link in the description that you can use for moving wires around. It's much easier because you can squeeze without worrying about clipping a wire. However, I've been doing this for over 15 years. I think the first pedal I built was in 2008. And I've been building solidly as Hello Sailor Effects the second time round since 2017. But that's a whole other story. So there's our input and output wires now sorted. Next is our circuit. So this lug here is going to go to our circuit board, whatever you use, whether it's a PCB, tag board, or strip board, whatever. That's going to be the part of your drawing that's marked in on the circuit goes to this here. This bit here is the output, and that is the part of your circuit that's marked out. Usually for an overdrive, or commonly for an overdrive, it will be that the volume pot, the center lug of the volume pot. It can be straight off the PCB or off the Vero board. Who knows, different pedals, different layouts or whatever. However, for the Kossoff drive, it comes off our volume pot. So that center lug there is our output of the circuit going to there. So I'm just going to wire that in now. When it comes to solder here in the UK, it's a bit difficult. We don't really get the leaded solder that you can get in abundance over in the US. It's such a shame. Of course, if you're thinking about selling your pedals in the future, leaded solder is not ROS compliant, so you won't be able to sell your pedal abroad. If this isn't a concern to you, then I advise getting leaded solder. However, if this is a concern to you, then the main thing you want to look for, in my opinion, is a solder that has rosin core, so then it's going to help it flow. It'll have some flux in there. And I aim for a 0.7 or 0.6 millimeter diameter. The thin diameter really helps the solder flow. Now, of course, everybody's different, and everyone has a different preference when it comes to solder. I suppose the key is you've got to try a few and see what you like. So that's our output now coming from this pin here on our 3-pole double throw switch round and to our circuit. In my case, it's this pot. In your case, it could be something else. And don't forget, this one on the opposite side here is the input to your circuit. I know I'm banging on about it, but if you mess up the input, your pedal will never work. Next, we're going to tackle the earth, or the ground. I keep getting told off for calling it earth. So on board a warship, we call it earth because the ship's hull is metal. So all of our grounds go to earth through the ship's hull. Anyway, doesn't matter. I did say before that I like to join these two jacks together, and I usually do that with some solid core cable. But rather than you paying out for an extra thing, i.e. a solid core cable, I'm going to use some of our silicone wire to make the solid core. All I'm going to do is measure between the two jacks on the top and the 9-volt jack there. and take that measurement and just strip that amount of wire. It's easier to do in 2 or 3 bites, if you like, rather than trying to strip the whole thing, because it's a lot to come off. It's a large amount of outer cover to come off. So 2 or 3 bites will do it nicely. We give it a twist. Right, and then once we've given it a twist, it's handy to lay it over something. In this case, it doesn't want to lay on my enclosure, which is fantastic. We lay it over something, so then I've got access to it. And this is where your solder dispenser and wire dispenser really comes into its own. And then I'm just going to tin down the whole length of this wire. This is also where doing this, tinning this long bit, is where in the past, traditionally, sorry Hayley, I've drop soldered on my wife's dining room table before I started working before I started working out in the workshop or whatever. It used to be set up on the wife's dining room table, and I'd drop a blob of solder on there, she'd go mental. Fun times. If you're worried about that, then why not get one of these nice solder mats? The fuck cannot go wrong. Anyway, so when we're using our solid core, I'm going to feed it through this pin here on the 9-volt jack. This is the earth. So it goes through there, then it goes to our output jack earth, and then it goes to our input jack earth. And usually I bend them down so then they're flat. No reason really, I just like to do it. To get it through our 9-volt jack, it's handy if you just give it a little bend like that. That means that you'll be able to hook it in, because if it's a straight line, you're right up against the enclosure, and the chances of you getting it in while it's straight are not all that high. So once it's all the way in, I like to just solder the 9-volt jack part. If I can ever untangle my wire, get on. Yeah, just solder this 9-volt jack part in place. And that means that now, no matter what happens, that wire isn't going to move. I also like to lie it over the top of this lug here without going through the hole, and then go through the hole on the input jack. And you may be thinking, why on earth would you do that, Joe? And that's a very valid question, and I'll get to it now. So once that is in, I pull it through and give it a little bend, and then I'm going to solder the input lug itself in place so it can't go anywhere. There's our main earth soldered in. Now with this bit, what I like to do is I'll solder away from the hole and just onto the pin and leave that hole visible. And that gives me a place to go to with any earths from the circuit that I might want to add in afterwards. Obviously the circuit's going to have a ground, isn't it? So that ground can then run to this hole here without having to hook and loop over the buzz bar, which you can do. It's not a buzz bar, is it? Over the earth. Or you could just go through this hole. It makes it nice and easy. As you can probably tell, I've spent a lot of time soldering these pedals together and thinking about this pointless stuff. Now, as far as your earth goes, as previously stated, one earth will go to the circuit. Likely, some of your pots will have connections to earth. I'm not going to wire them in now because your pedal will be completely different depending on the circuit you're building. But what won't be different is the fact that you will have to send a ground wire round to your switch for your LED. Okay, so I like to do that in the same manner. I send the wire round. People may have seen me do this before. I like to use a screwdriver just to manipulate the wire into place. I mean, you can make this as messy as you like. It really, I don't think it matters that much in a 9-volt circuit, if I'm being honest. Unless it's something like a really susceptible fuzz or something. For an overdrive or whatever, I don't think it matters. Anyway, this earth goes to the front pin, the same, or the one that's in line with your input and output to your circuit. It goes to the front pin. Okay, so there it is there. I've measured it out. I'll just give it a snip, strip the end, and give it a tin. Now I can slot that into that front position. This will become apparent in a bit later on. Ooh. There are actually plenty of ways to wire up these 3-pole double throw switches, and if you've bought a kit, you really can't go wrong with wiring up how it tells you on the kit. However, this is how I wire them up, and how I've been wiring up my pedals for a number of years now. So there's our 9-volt in there. It's annoying me that that's sticking up on end, but whatever. There's our 8th in there. Next, we're going to move on to the live. Now, the live is the other 2 lugs or the other 2 pins on our 9-volt jack here and here. Center one is for the battery, and the bottom one is for if you're going to your circuit without a battery. For me, I absolutely never ever put batteries in pedals unless it's something like a germanium fuzz face and it's a PNP transistor germanium fuzz face. That's it. I really don't use batteries. I think it's pointless. You might as well just use a power supply and have a massive pedal board and just buy some of the gig rig power supply gear and get it sounding amazing. However, for this purpose, for me, if it's your first pedal build, you're either going to be using the 9-volt jack or the battery, not both. That's my advice. So in this one, we're using a 9-volt jack. What I do is I strip a wire, tin it, and put the wire through both lugs and then solder it. Well, I'll solder it to one first. I'll show you that. So if I strip this wire, I strip a good amount of it. That's way more than I'm going to need, but it's better to have more than less, because if it's too short, you'd have to, redo it. Whereas I've got a ton of this wire, even though it is like £10 a roll or whatever. I've got a ton of it, so I don't need to worry about that. And what I do is I thread this through the bottom lug and into the top lug. It's a bit of manual dexterity gymnastics here to get this in.
6.5 hours later.
Right, as you can see, I've got the wire coming through the bottom lug, going through and attaching to the top lug. I'm now going to solder just the top lug. Like so. The reason why I'm soldering just the top lug and not the bottom is because this wire now is going to run right the way around the enclosure and go to our LED, which is going to be situated over in this corner here. So I'm going to give myself plenty of wire to get right the way around there and give it a snip, and then we'll come back to that in a second. I left this hole here without soldering it. The reason being is our PCB or our tag board or our Vero board is going to require a 9-volt power supply to make it work. Of course it is. So I've left that hole there so you can run the wire around from your PCB or from your circuit and attach it right there, solder it on, and then you've got 9 volts going to your circuit as well. Now that we have our enclosure all wired up and ready for the circuit, it's time to talk about what circuit should you build for your first guitar effects pedal. Now, I highly recommend the Baz Fuss circuit. It doesn't have very many components, it sounds great, and it's a simple build that really you can't go wrong. If you're looking for something a little bit more complex, then how about the electric distortion? That adds clipping diodes into the mix, which makes it a bit more complex, but then again, a bit more rewarding. You could always take the plunge and watch one of my other videos and build a bit more of a complex pedal on tag board. Now onto the LED. I highly advise you use the bezel mounting LED that comes with your kit. It just makes things easier. I like to do it a bit different. I glue my LED in place and then use steel reinforced epoxy to hold it in, and I have a different bezel mounting system. Whatever. Either way, when you're mounting your LED, try and mount it so the longer leg is pointing up to the top of the enclosure and the shorter leg is pointing back. This is because the earth is pointing backwards and the live is pointing forwards. The reason for that, and here we go, is because our current limiting resistor is going to come from our switch round the back here and attach directly onto our LED negative terminal, like that. And if the negative is at the back, it's much easier to attach it. And then all we do then is run our live wire round the enclosure and attach it onto the other leg. For me, I've got this 2.2k resistor. Usually I use between 5 and 10k, but I like the fact that this is an old resistor and it's going to look good in this pedal, so I'm using it. It might be a bit bright. All I do is I take a pinch at the end, use my Knipex snips as a straight edge and bend it round 90 degrees. I snip off a bit of excess. If it was me, I would measure out the excess, but because I've built loads of these, I can do it by eye, if you like. Not the best way of doing it, I must admit. And then I thread it through the 2 remaining holes on the 3-pole double throw switch. The only hole that matters is this center lug. That's the one that you need to solder, okay? I do, however, solder this other hole just because it's going through there. I might as well solder it. I don't know why, whatever. In fact, I probably should leave that not soldered and show that I'm using gold pin 3-pole double throw switches, now I think about it. Anyway, our other leg over here, if I snip the excess off so then it can actually fit in the enclosure, can come down and marry up with the negative side of our LED. Give it a little bend, it should go right in there. Like so, and then if I just give that a solder, again, diodes are sensitive to heat, and LEDs, light emitting diodes, are in fact diodes. So you don't want to hang about on your LED too long if you're soldering it in. But at the same time, and this does come with practice, don't be scared of soldering it. Some people are like tentative and don't hold the heat on for long enough. You get a dry solder joint, the pedal never works, or the LED will never turn on, or whatever it is. Now, our live from before is going to run right the way around the outside edge. If I can tuck it in there properly, well done, Joe. It's going to run right the way around the outside edge, and then I'm going to take I'm going to snip it to length first, and then I'm going to strip the end, tin it, and then using my Knipex snips, this is, I mean, people hate doing this bit or whatever. Some people would just take that and rest it up against the live pin. For me, what I like to do is just create a little hook. Oh, look at that. I've just snipped the wire with my snips. That can happen. Get a little bit too excited and squeeze a bit too hard. What can I say? I'm shy on camera. Not. Right, so I make the little hook and then bend it round and hook that round the live terminal. As so. And then I can solder that hook. It just gives it a bit of a better mechanical connection, if I'm honest. If I solder that should hold it on there. Snip off the excess. And that is our LED wired in. The next step for me would be to add the circuit board or the PCB, wire up all the terminals from the PCB to the various positions, ensuring that, I've left a little bit of thing there, ensuring that we have power to the circuit and our output from here is attached to, our input from the switch is attached to the input to the circuit. Then it will be ready to go. Before we do anything else, let's just check that our LED does in fact work. And there you go. As you can see, it's a little bit bright because I used a 2.2k resistor. Shout out to DevTech Audio, by the way. The pedal he sent me, the fuzz, has like a little trim pot inside to dial back the brightness of the LED. I think that's fantastic. And the LED also changes colour, which is amazing as well. The main thing about starting guitar effects pedals for the first time is just to remember that 90% of us don't build a working pedal on our first try. I most certainly didn't. I was trying to use thick, big, old vintage components with a soldering iron that wasn't up to the task, at sea on a warship with lots going on around me, and I must have built at least 20 pedals before I got one to work. If your pedal doesn't work when you first turn it on, don't panic. It's just a case of checking over all your solder joints and checking the wires are going to the right locations. 9 times out of 10, you'll find something that hasn't been soldered properly or you've put it into the wrong position. It's not a big hassle and it's all part of the fun. I would love to hear what guitar effects pedals you guys plan to build in 2025.